In this video, we are going to cover a few of the features supported by Project Antrea. The idea is not to give a complete overview of the project, but rather to highlight some of what you can do. We will take a look at Kubernetes network policies and how to use the Antrea Octant dashboard plugin to generate Traceflow requests and troubleshoot connectivity issues. We will also look at some of the cloud-native tools that Antrea integrates with to provide more visibility into the cluster network. So let's go ahead and create a Kubernetes cluster in which we're going to deploy Antrea. To create this cluster, we use K8s, which is a cluster lifecycle management tool. And we're going to create this cluster on AWS, and we're going to provide the CNI networking option to ensure that pod networking is provided by a CNI plugin. It takes a few minutes to create a cluster, but once it's done, we can see that we can use kubectl directly to access the cluster. So let's go ahead and take a look at the nodes in our cluster using kubectl. Right now we have 3 nodes in the cluster, which is what we requested from K8s, and they're all in the not ready status. And that's because we haven't deployed a network plugin, a CNI plugin, in the cluster yet. So let's go ahead and download the manifest for the latest version of Antrea. And we're going to take a look at it first. And what we're going to do is we're going to edit some configuration parameters to enable some features in Antrea which are currently disabled by default because they are considered alpha. Such features are Traceflow, for example, which we're going to take a look at later, and the ability to expose Prometheus metrics. So we can now apply our modified YAML manifest and deploy Antrea in the cluster. And let's take a look at the pods while they're coming up. All those pods are going to be in the kube system namespace. We can see that we have 3 different Antrea agent pods, one for each node, and that's because the Antrea agent is run as a daemon set, and we have one Antrea controller pod. The Antrea controller is run as a deployment with a single replica, and it takes those pods about 1 minute to come up. Now let's look at our nodes one more time, and they should all be in the ready status, and that's the case. So now that our cluster is ready, we can go ahead and deploy some workload pods. And first we're going to create a deployment with 3 Nginx web servers. So let's take a look at those pods. They should come up pretty fast. We have 3 of them as expected. We can also see which nodes those pods are running on. We can see that one of the nodes is running 2 replicas and one node is running a single replica of the Nginx web server. Let's take a look at the Antrea pods running in the cluster as well. And let's take a look at which nodes those pods are running on. We're going to locate the agent pod, which is running on the node with the 2 web server replicas. And we're going to exec into that pod. By execing into that pod, and more specifically in the Antrea OVS container, we're going to be able to inspect some networking configurations. So we can see that we can run the OVS vsctl command line tool to look at the ports on the OVS bridge. And we can see in particular that we have 1 port for each of the web server pod. And we also have our tunnel port for the overlay traffic. We can also use a different OVS command line tool, OVS ofctl, to dump the flows for the bridge. And as we can see, it can get quite complicated. That's why for Antrea, we developed a command line utility called nctl. And we developed such a tool to be able to present this information in a more user-friendly and simpler way. So let's take a look at the available commands for nctl. And more specifically, let's take a look at the get command. And we can see that the get command has a subcommand called pod interface to print information about a pod's network interface, the network interface which is created by Antrea. And we can see that we have the information for each pod which is currently running on that node, in particular the 2 web server Nginx pods. We can also use that other subcommand called OVS flows, and we can see that instead of giving us a dump of all the flows, we can actually filter flows based on the pod name, for example. By using this command, we only see the flows which are relevant to that specific pod. So let's take a look now at Kubernetes network policies and their support in Antrea. As a reminder, this is the web server deployment that we created previously, and we're now going to create 2 new deployments, one called web client and one called other client. And the pods in those 2 deployments are going to be labeled differently. So let's apply those 2 YAML manifests to create the web client pods and the other client pods. And let's now take a look at all the pods we have running in the cluster in the default namespace. And okay, we can see the 3 web server pods, 3 web client pods, and 3 other client pods, and they're all running and ready. Now let's exec into one of those web client pods and make sure that we can access the web server service. So we're just going to use curl to do an HTTP request to the web server service, and that request is going to be load balanced to one of the 3 web server pods we have in that deployment. And we can see the welcome to Nginx message, which means that the web client pod is able to access the web server service. Let's do the same thing, but now with one of the other client pods. It's going to do exactly the same HTTP request, and we're going to get exactly the same welcome to Nginx message. And right now we don't have any Kubernetes network policy applied to the cluster, so it makes sense that all pods can communicate with each other. But let's go ahead and take a look at an example policy. This one applies to all the pods with the web server app label, so our web server deployment, and it defines one ingress role that says that only web client pods can communicate with web server pods, and only using TCP on port 80, so only using HTTP. We're going to apply that network policy, and then we're going to exec one more time into the web client pod. Same web client pod as before. We're going to do the same curl HTTP request, and we can see that we get the same success message. Now let's go ahead and exec into the same other client pod as before, and let's attempt the same HTTP request using curl. And we can see that now the command hangs. We're no longer able to access the web server service. Let's now switch to the Octant dashboard and see what kind of information you can get there about Antrea. So Octant is a web dashboard for Kubernetes, and by default it lets you visualize your Kubernetes resources, such as pods. Here we're looking at one of the Antrea agent pods running in our clusters. We can see information about it, we can see logs for it in a centralized location. For example, here we see logs about the creation of a new pod and Antrea provisioning as a network for that pod. But Octant also supports the notion of custom plugin, and in the case of Antrea, we wrote our own Octant plugin. It displays runtime information about the different Antrea components, for example, the different agents running in the cluster. But more interestingly, we provide the ability to generate tracing requests between pods in the pod network to troubleshoot connectivity issues. In this case, we're generating a tracing request from one of the web client pods to the web server service. And we're using destination port 80 and the TCP protocol. So based on the current network policies in our cluster, this tracing request should succeed. I'm going to wait a few seconds, and here we go. We get a graph to show us the progression of the tracing packet through the pod network. We can see that the packet went from a source node to a destination node, and we can see the different stages of packet processing on each node. Let's now generate a second tracing request, slightly different. This time, as the source pod, we're going to use one of the other clients instead of one of the web clients. The rest of the query is going to be exactly the same. The destination is going to be the web server service again. The destination port is going to be 80, and once again, we're going to be using TCP. Let's wait a few more seconds for the result to appear. Okay, and we see a very similar graph as before, except this time the packet is dropped at the destination node as expected when it's dropped because of an ingress policy rule. The Antrea version we're using right now supports an experimental feature called NetworkPolicy Stats, which lets us query statistic information about each network policy applied to the cluster. For the WebNP policy here, we can see the number of bytes, packets, and sessions allowed by the policy. Let's now exec into one of the web client pod and do an HTTP request for the web server service again. And let's see how it affects the statistics for the policy. We can see that the statistics haven't changed yet, and that's because in Antrea we lazily update those stats to avoid putting too much of a burden on the cluster. But if we wait for a few seconds, we can see that those 3 counters for sessions, packets, and bytes are finally updated. So let's get back to our cluster and see what kind of tools Antrea supports to provide visibility into the cluster network. First thing we're going to do is deploy some application workloads to the cluster with web clients and web server. But unlike before, the web clients are constantly going to be opening new connections to the web servers now and downloading a lot of content. And as you can see, I've already deployed Prometheus to the cluster, and it's exposed as a node port service. So let's get one of the node's external IP here, which we're going to use to access this node port service. And let's move on to a Grafana dashboard, which I'm running locally on my laptop. The first thing we're going to do is we're going to add our Prometheus service as a data source for Grafana. Once this is done, we're going to go ahead and create a new Grafana dashboard, which we're going to use to visualize one of the Prometheus metrics exposed by Antrea. So let's configure our dashboard, and we're going to go ahead and take a look at the list of available metrics from Antrea. And we're going to select one of them as the number of Antrea connections committed locally by each agent to contract. And we're going to have 3 different values available here because we have 3 different Antrea agents running in the cluster. And as we can see, for 2 of those agents, the number of connections is steadily increasing. Those are the 2 worker nodes in our cluster which are running web server and web clients. So let's now take a look at another tool I can leverage to understand what's happening in my network. And let's take a look at the ELK flow collector namespace in my cluster, and you can see that I've already deployed an ELK stack in my cluster. For example, I'm running logstash here as a cluster IP service. I'll take a look at the Antrea YAML manifest and make sure that Antrea was configured correctly. So let's take a look at the config map, and we see that for each agent, we enabled the flow exporter feature, which instructs the agent to export flow information as IPFIX flow records, and we can see that the flow collector address we provided matches the cluster IP address for the logstash service. We're also running Kibana as a node port service, and we're going to be able to access it through a browser. This first pre-configured Kibana dashboard shows all the IPFIX records received from Antrea agents. And if we look at the details of one such record, we can see that we have some standard IPFIX information elements, for example, destination IPv4 address, but we also have some Kubernetes-specific information elements added by Antrea. For example, source pod name, source pod namespace, service name when applicable, and so on. Let's now take a look at the second pre-configured dashboard, which includes flow diagrams for all the traffic traversing the cluster network. The first diagram shows the throughput between each 2 pods in the cluster. In our case, it shows the amount of traffic generated between the web client pods and the web server pods. The second diagram shows the same thing, but this time using the service name as a destination. In our case, we have a single service in the cluster. And finally, we can see some other diagrams showing the evolution of the throughput over time. Thanks for watching. If you have any questions, please reach out to us on GitHub or on the community Slack channel.